Hello guys, welcome back to our YouTube channel. Guys, you all know that we have started with a series of videos on pump. So continuing the series, particularly in this video, we will be talking about centrifugal pumps. More precisely, for this video, we will be talking about the components or the construction of the centrifugal pump, and followed by which we will discuss about the working of centrifugal pump. Okay guys, so now let's get started with firstly, what is a centrifugal pump? Guys, I think that you all might have heard about centrifugal pump either in your academics or while you are working in industries, right? But now here, talking about the definition of centrifugal pump, a centrifugal pump is a type of dynamic or kinetic pump which is used to transport liquid by converting it from mechanical energy from a motor or an engine into a kinetic energy in the fluid. Okay? It operates based on the principle of centrifugal force, and it's most commonly used in various industries for transferring liquids such as water, chemical, petroleum and sewage. Okay? So in simple words, guys, centrifugal pump works on the principle of centrifugal force, and it is a type of dynamic pump or a kinetic pump which is used to transport the liquid from one stage to another stage, and which is done by converting the mechanical energy which is obtained from the motor or engine and converting it to kinetic energy in the fluid. Okay guys, so I hope the basic definition of centrifugal pump is clear to you. Now moving on with the main components or the construction of centrifugal pump. The first component is the impeller. Guys, the impeller is a rotating component with curved blades or vanes. Its primary purpose is to impact the kinetic energy to the fluid by accelerating it radially outward. And guys, the design of impeller influences factors such as flow rate, pressure and efficiency. So we can call it as the heart of the centrifugal pump. Okay? Guys, now the second component is casing or volute. Guys, the casing, also known as the volute, is a stationary outer covering that surrounds the impeller. Its main function is to collect the fluid discharged from the impeller and guide it towards the pump discharge outlet. The casing also helps to convert the kinetic energy of the fluid into pressure energy. So guys, the purpose of impeller is to generate energy for the flowability of the fluid in radially outward direction, and the purpose of casing or volute is to provide a proper direction to the fluid. Okay? Then the next component is the suction inlet. Guys, a suction inlet is simply just an opening through which the fluid enters the pump, and it is usually located at the center of the impeller. The suction inlet may include components such as the strainer or filter to prevent the debris from entering the pump and to prevent the causing of pump getting damaged. Okay? Guys, now the next component is the discharge outlet. Guys, the discharge outlet is a point where the fluid exits the pump after being pressurized by the impeller, and it typically locates at the periphery of the casing. Okay? Guys, now the next component in the assembly of centrifugal pump is the shaft. Guys, the shaft is a mechanical component that connects the impeller to the motor or the engine that drives the pump, and it transmits rotational motion from the motor to the impeller, allowing the impeller to rotate and pump the fluid. Okay? Guys, now the next component which we are going to discuss for centrifugal pump is bearings. Bearings supports the shaft and allows it to rotate smoothly. They help to reduce the friction between the shaft and the stationary components, and thereby minimizing the wear and ensuring efficient operation of the pump. Okay? Guys, then the next component is seals. Seals are used to prevent the leakage of the fluid from the pump, and they are installed at various points where the rotating shaft penetrates the casing. Common type of seals includes packing seals and mechanical seals. Okay? And the last component of centrifugal pump is wear rings. Guys, wear rings are stationary components which are installed between the impeller and the casing to minimize the wear and maintain hydraulic efficiency. They help reduce the clearance between the impeller and casing and thereby prevents fluid recirculation and improves pump performance. Okay? So guys, these were some of the main components of centrifugal pump. Guys, these components work together to facilitate the transfer of fluid from the suction side to the discharge side of the pump, and which is by generating flow and pressure according to the requirement of the application. Okay guys, so this was a brief construction of centrifugal pump. Up next in this video we are going towards the working principle or the working of centrifugal pump. Guys, the working principle of centrifugal pump involves the conversion of mechanical energy from the motor or the engine into kinetic energy in the fluid being pumped. Guys, here's a step-by-step explanation of how a centrifugal pump works. The working of centrifugal pump starts with the fluid intake. Okay? The process begins when the fluid enters the pump through the suction inlet, which is located at the center of the impeller. And this can be achieved through gravity, suction pressure, or external forces depending on the application. Okay? Now after the fluid intake comes the impeller rotation part. Guys, the impeller, which is a rotating component with curved blades or vanes, is driven by the motor or engine via shaft, right? And as the impeller rotates, it accelerates the fluid radially outwards due to the centrifugal force. Okay? After the impeller rotation comes the part of fluid acceleration. The rotation of the impeller imparts kinetic energy to the fluid and causing it to move from the center point towards the outer edge of the impeller. Okay guys, so let's quickly recall the 3 steps or the 3 working steps of the centrifugal pump, from which the first was the fluid intake, where the fluid enters the pump at the center of the impeller, after which comes the impeller rotation part. And in the case of impeller rotation, the impeller rotates, causing the fluid to flow radially outward direction, which is because of the centrifugal force, right? And as because of the impeller rotation, the fluid acceleration takes place, right? After the fluid acceleration comes the pressure increase. Guys, as the fluid moves towards the periphery of the impeller, it experiences a decrease in pressure energy, and along with heat, an increase in kinetic energy. And this is a result in increase in the velocity of the fluid and the pressure within the pump. Okay? So at this stage of point, a pressure is built, a fluid velocity is increased, and the fluid is now ready to get discharged. Okay? So now comes a part of fluid discharge. Guys, the high pressure fluid is discharged from the impeller into the casing or the volute surrounding the impeller. The volute is designed to collect the fluid and guide it towards the discharge outlet of the pump. Okay? And guys, here also comes the conversion of kinetic energy to pressure energy. As the fluid enters the volute, the gradual expansion of the casing converts some of the kinetic energy of the fluid into pressure energy. And this leads to increase in the pressure within the pump, enabling the fluid to be pumped to the desired location. So guys, at this point of stage, the fluid has gained a proper energy and the pump is also pressurized. Now it is a proper time for the delivery of the fluid. So guys, the pressurized fluid exits the pump through the discharge outlet and it is delivered to the desired location, such as pipeline, storage tank, or another part of the process. Okay? And guys, in some of the cases, a recirculation line or a cooling is to be provided to maintain the temperature of the pump. As the pump gets pressurized, the temperature of the pump also gets increased, and which causes or increase the probability of the pump getting damaged. So due to which a recirculation and a cooling assembly is provided in some of the centrifugal pump. Guys, some of the centrifugal pump may have features such as recirculation line or cooling jackets to maintain the fluid temperature and prevent overheating during the operation. Okay? Guys, throughout this process, the impeller continuously rotates and creates a continuous flow of fluid through the pump. The efficiency and performance of the pump depend on factors such as impeller design, operating speed, fluid properties, and system requirements. Okay? So guys, this was the overall working of centrifugal pump. Talking about some of the application, centrifugal pump are widely used in various industries for applications such as water supply, wastewater treatment, chemical processing, and even in HVAC systems due to their reliability, simplicity, and versatility. Okay? Some of the application of centrifugal pump includes water supply and distribution, wastewater treatment, chemical processing, then even in oil and gas industry. It is also used for generation of powers, then it is also used in HVAC systems. Some of the application is also there in marine applications. It is also used in some of the agriculture sectors, then food and beverage industries, even in mining and mineral processing. In general, it is used in mostly each and every type of industries which are operated worldwide. Okay? So guys, that's all for this video where we discuss about what is a centrifugal pump, then components or construction of centrifugal pump, followed by we discussed about the working of centrifugal pump, and at last in short we discussed about the application of centrifugal pump. So guys, that's all for this video. Hope you like this video and thank you for watching. And guys, for more video related to chemical engineering, process engineering, chemical safety, industrial safety, you can subscribe to this channel. And guys, as always, feel free to leave any questions or comment down below. Thanks for watching and see you in next video.